Hey guys, welcome back. It's Addison.
And Kylie.
And today we're going to go in depth about heart scans.
Addie and Kylie, the Science Gals.
Science rules.
Before we start off and talk about heart scans, let's talk about the background information on how chemical reactions differ from nuclear reactions. Nuclear reactions involve a change in an atom's nucleus, and the reaction produces a new element. Chemical reactions involve a rearrangement of electrons and do not involve changes in the nuclei. Chemical reactions can be influenced by pressure and temperature, whereas these factors do not cause a nuclear reaction.
Remember those small little atoms? Well, they're involved in nuclear and chemical reactions. You want to know why?
Yeah.
Well, in a chemical reaction, the valence electrons are involved, but in a nuclear reaction, the nucleus is the part of the atom that's involved.
Some people may wonder how much relative energy is changed in a chemical and nuclear reaction. Energy absorbs to break bonds in a chemical reaction, whereas the energy in a nuclear reaction is released.
What happens to our atom here when it is involved in a chemical or nuclear reaction? Well, the electrons in a chemical reaction may be added or removed, but the nucleus will stay the same. In nuclear reactions, the neutrons and protons change the atom, and when the proton changes, that will make a new element.
Temperature, pressure, concentration, and catalysts all affect the reaction rates. An increase in these elements will cause a higher reaction to occur in a chemical reaction. The reaction in a nuclear reaction is not dependent on temperature or the concentration.
There are two things, nuclear fusion and nuclear fission.
What is the difference?
Nuclear fission is a nuclear reaction where the nucleus of the atom splits in two or breaks down into smaller nuclei. What causes the split of the nucleus is either the nucleus is too big and heavy, or the atom makes impact with another particle, which causes a release of energy. The energy released is a large amount of energy.
Now that we know what nuclear fission is, let's figure out what nuclear fusion is. Nuclear fusion is a reaction where two or more atomic nuclei, usually deuterium and tritium, combine to form one or more atomic nuclei and subatomic particles. The difference in mass between the reactants and products is manifested as either the release or absorption of energy.
There are three types of energy. There are three types of radiation, and they are pretty different from each other. We have alpha, beta, and gamma. Alpha and beta particles have energy and mass, whereas gamma rays are pure energy. Alpha has a very low penetrating power, beta has intermediate power, and gamma has very high power.
First, we have to figure out how heart scans are used and who uses the product. Heart scans are x-rays to create detailed pictures of the heart and their blood vessels. This test is called the coronary calcium scan to see if there is a buildup of calcium or plaque in the arteries. The people who use the heart scans have some type of chest pain and shortness of breath, and the scans check for issues in their arteries or valves.
Adding on to that, heart scans work by taking a picture of your heart while you're in the scanner, and it takes about 10 minutes for it to finish. The scanner does not cause any pain. If you score a 0 on the scan, then you are at a low risk for a heart attack. But if your score is higher, then you're at more risk for a heart attack.
Who invented the heart scans and when? Arthur Eggleston and Warren Janowitz invented the heart scan in 1990.
Out of the three nuclear radiations, heart scans use not alpha rays or beta rays, but gamma rays. These gamma rays are detected when using the machine's special camera and a computer to create images of the insides of the body.
What are the benefits of a heart scan? Heart scans help the doctor discover the amount of calcium in the heart and what is the risk for the patient in the next 5 to 10 years if they have a heart attack. Heart scans are beneficial to the user because it will show you what is wrong with your heart and if you are likely to have a heart attack. This scan can help save your life.
Although there are benefits to doing a heart scan, there are some health risks that should be looked into before doing a heart scan. These health risks are there's a slight chance of getting cancer. In the heart scans, there is radiation that could potentially give you cancer. The amount of radiation from one heart scan is about how much radiation you would see in a year. So there is a big slight chance that you would not get cancer, but there is still that chance.
What byproducts are created from a heart scan? The byproducts created are radiation and radioactive waste or decay. The scans produce small particles called positrons, which are particles with roughly the same mass as an electron, but it is oppositely charged. There is a dye that gets inserted through your veins, and this is what shows the doctors if you have any problems. So they will insert this dye through an IV, and it will change the vein color in your heart. By drinking water, this will help the dye leave your body naturally. If you have any complications with the dye, you have to take antihistamines, steroids, and/or histamine blockers, which can help with a negative reaction to the dye.
After learning about the ups and downs of heart scans, I think it's pretty obvious that
You should go get one. It could potentially save your life. If you're having chest pain or any sort of shortness of breath, go get a heart scan.
you will not die. Thank you all for watching.
If you liked our video, subscribe for more.
Like and subscribe.
Addie and Kylie, the Science Gals.